Let's have some more transactions. Which one are we doing? We're doing bait and switch. Okay, we got two transactions, A and B. They're both written in terms of assignment, sequencing, and locks. Funnily enough. So you can see that A is atomic. On the inside, it messes with X and Y in some funny way, and on the outside, it locks exactly the things it's messing with. Okay? So whatever happens, assuming there's no deadlocks, if A can manage to take its locks, it will execute as if it's a single action. B, on the other hand, is much, much messier. B has no locks at all, and it's doing two memory changes. It's first of all adding 50 to Y, and then it's adding 50 to X. So there's no locking. So if A and B were to run concurrently, it could interfere with B at any point in the process. Trouble. What is B's process? Let's figure that out. B needs to compute, first of all, this assignment to Y. So B is going to read Y, and then it's going to write Y, and then it's going to read X, and then it's going to write X. Okay, so let's get on with the questions. We were told that initially X is 20 and Y is 10. And we're asked, identify all possible outcomes if A and B execute in sequence. So that means if A executes then B, or B executes and then A. Okay? So let's figure it out. Let's suppose A goes first. Let's just calculate it. A goes first. We start with X is 20, Y is 10. Okay, let's do A's first instruction. We add Y to X. So that means, X is X plus Y. That means we get X being 30 and Y being 10. Next we have Y equals X minus Y. Okay, so this time X stays the same. And Y, what's X minus Y at this point? 20. And then finally we do X equals X minus Y, except of course that there's been some change. What happens now? Well, Y isn't changing, so it's going to stay 20. What does X become? 10. Notice anything about the relationship between X and Y at the end and X and Y at the start? They've swapped. And in fact, that's not at all a coincidence. If you work it through, you'll see that A exactly swaps X and Y. This is one of the classic ways to swap the values of two variables without using a third variable. You'll notice that we always have all of the information at all times. So yeah, so A atomically swaps X and Y. Right, cool. So if A goes first, we'll end up with x is 10 and y is 20. What will happen if B goes, then happens? Well, they'll both go up by 50. So that's to say we'll end up with x equals 60 and y equals 70. What happens if we do B first? We add 50 to both and then swap, we'll get the same answer. Okay. So, next we are asked identify the outcomes which are possible if A and B execute concurrently apart from those in your answer to part A. So let's figure out how to think about that. Remember, this is what B does. And because B doesn't take any locks, A could execute at any point in the process. So, there are 5 places during the execution of B in which A could happen. But because A is atomic, we can treat A as happening all at once. So A could happen here, and we've already covered that one. That would be A goes first, and then B goes afterwards. A could happen here, and that would be the same as B goes first and A goes afterwards. So we've covered that one as well. But there are 3 other possibilities. A could happen there, A could happen there, or A could happen there. A is going to swap the values. Okay. So, let's figure out what happens in each case. Right? Let's do this one. Okay, remember initially x is 20, y is 10. Okay, so what happens, B will read the 10. Remember, B is adding 50 to both. B will read the 10. A will swap, so at this point we'll have x is 10, y is 20. And then B will write. B will write the old value of y plus 50. So this write will make y equal to 60, and x will still be 10. And then the rest of B will add 50 to that 10. So we'll end up with x is 60, y is 60. Okay. What happens if A happens right in the middle? Okay? So we start off with 20 and 10, and then B does its read and write on y. We now have 20 and 60. Everybody cool with that? Then we swap, so we've got 60 and 20, and then x gets another 50, so we've got 110 and 20. Right, the swap happened after y got 50 and before x got 50, which means x ended up with all the loot. Okay, what happens with the last one? Well, we get this far. Let me do that in black. So we're looking at A happening here. So we end up with x is 20, y is 10. By the time we get to here, we have x is 20, y is 60, and B has already read the 20 from the x at this point. Then they swap. So that's x is 60, y is 20. And what is going to then be written into the x? 70, because it was 20 that got read. So we end up with x is 70, y is 20. So that's the other possibility. So there's three things that might happen in concurrent execution, because A can happen at any stage during the execution of B. Okay. Finally, suppose we replace the transaction B with B prime, defined as follows. B locks y, adds 50 to y. What can happen? First of all, can deadlock happen? This question has been designed to fool you into thinking that deadlock might happen, but it can't. Why not? Look at where the curly braces are. This process, this should be B prime, of course. This process will release its lock on Y before it attempts to take its lock on X. It's never in the situation that it's holding one lock and trying to access something else. So no deadlock here. Instead, all we've done is to exclude the possibility of these two. However, because there are no locks in the middle, like you see where the semicolon is? Whoops, let me get where the semicolon is. In the middle, no locks are held. So A could still happen in the middle. Correspondingly, we get the outcomes that correspond to here, here, or here. And we've already figured out what they are. Okay? So you're getting, I hope, the message of how to think about these things. If you spot that a process is atomic, that means it's just a question of when that process as a whole interrupts some other process that's happening. That's often very useful. Okay, how are you doing for 1 minute papers? Because I know quite a lot of people. Anybody need? Yeah. So